Hello, welcome to my mid-year symposium talk on a comprehensive look at type 1 diabetes. My name's Austin Bakke. Let's get started. So, first question, what is diabetes? Diabetes is a variety of autoimmune conditions in which the body is no longer capable of using insulin. There are two types, type 1 and type 2. Currently, in the United States, there are approximately 1.6 million people diagnosed with the condition, and that number grows every day. Most of them are type 2 diabetics, but today we will be focusing on type 1. Now, the difference between type 1 and type 2 could be seen here. On the left, there is someone with type 1 diabetes. You can see that there is no insulin to use because the body no longer makes it. However, on the right, they still have insulin, but their body is no longer able to use it. Either way, the cell is no longer getting the glucose that it needs because it's not able to use insulin properly in order to absorb it. Now, I've been talking about insulin quite a bit, but I have yet to actually say what it is. So, insulin is a type of hormone, approximately 50 amino acids long, in which our bodies use to help control blood glucose levels by helping muscle, fat, and liver cells absorb sugar that it requires to form ATP, thus lowering blood sugar levels. Essentially, it allows us to use the food we eat as energy. It's formed within the beta cells in the pancreas, and diabetics are unable to make it, and therefore they get it from other sources. The picture on the right is a representation of its tertiary structure, and I just think it's really interesting to look at. So, diabetes is able to produce a variety of symptoms, and all of them are caused by the body's inability to control its own blood glucose levels. A diabetic normally reads blood glucose levels using a device on the right, which is called a glucometer, in which it takes a small amount of blood, places it on a strip, and then it's able to read the concentration of sugar, in the blood. When the blood glucose level is below 100 milligrams per deciliter, it's called hypoglycemia or low blood sugar. And if it is above 160 milligrams per deciliter, your body undergoes hyperglycemia or high blood sugar. Both have different short-term effects that range from person to person that I will get to in a moment, but the long-term effects of not keeping blood glucose levels in check are what can prove deadly, ranging from blindness, kidney and liver neuropathy, and in some cases even amputation of the limbs. Overall, diabetes as of 2017 was the 7th leading cause of death in the United States, according to the American Diabetes Association. As for the short-term symptoms, these are the most common ones for high and low blood sugars. Low blood sugars are caused by too much insulin, normally resulting in the body having not enough sugar to use normally. This can result in sweating, a change of mood, hunger, dizziness, or the inability to concentrate, and in extreme cases can lead to loss of consciousness. In cases of high blood sugar, the body has no insulin to properly lower the blood sugar levels, and it requires the sugar to be released in other ways. This commonly results in sugar spilling into the urine. It can cause frequent urination and thirst. It can also cause blurry vision, weakness, dry mouth, and headache. In very extreme cases, it can also cause DKA, also known as diabetic ketoacidosis. So, ketoacidosis is a condition in which your body has too much sugar in the blood, resulting in a variety of new, more severe conditions and symptoms, as seen on the right. The high sugar content in the blood causes the body to release anti-regulatory hormones into the bloodstream, causing fatty-free acids and ketones to be released. This lowers the pH of the blood, turning it acidic. Now, these are the symptoms and concentrations of things that happen when the body starts going into DKA, ranging from blood glucose levels normally ending up to be over 250, and the pH lowering as it gets more severe. Now, normally the body is able to fix the acidic blood through the release of bicarbonate and other type of buffering systems, but in these cases it happens so severely that the body is no longer able to release enough to fix the issue. So, the question remains, what causes these symptoms? The answer is still not entirely known, but it is known that it's through a combination of environmental factors interacting with the genetics of an individual. And this results in an autoimmune response that destroys the beta cells, resulting in insulin no longer being produced. Now, this is an image captured at the Perelman School of Medicine in Philadelphia of an islet cell, which is where beta cells normally reside, along with alpha cells that create glucagon, as seen in brown. Glucagon is what raises blood sugar, while insulin lowers it. On the left, you're able to see an islet cell before the immune response, where the beta cells in red have yet to be targeted, while on the right, a type 1 diabetic, after the immune response, no longer has the beta cells, and that means that insulin is no longer able to be produced. Luckily, however, there are treatments. So, insulin has been used to treat diabetes for over a century, and it does come in a variety of forms that act at different rates depending on what is needed, as shown on the right. Something I didn't say before is that I actually am a diabetic, and I use Lispro or Humalog every day. It's able to be given through hypodermic injections or through a device called an insulin pump, and this gives small amounts of insulin through the day based on a metabolic rate that ranges from person to person. Diet and exercise are also able to affect the body's ability to absorb insulin, and therefore quite a few diabetics normally have some sort of nutritionist or exercise or diet plan. New treatments are also being developed all the time. For example, inhalable insulin is now available. It comes in a small tube in powder form, and it works in as little as 12 minutes when inhaled, which is much faster than anything else I've seen. And finally, I want to show that there actually is hope. So this is a New York Times article from last week. It's about a clinical trial that's taking place right now at Mass General in Boston. In it, they're implanting stem cells that can produce insulin without an autoimmune response, and the results are frankly amazing. Some individuals that have gone through this have shown a 90% insulin production rate, which is almost close to what a normal person would be able to make. Essentially, the person is cured of the condition. And personally, it gives me hope. It means that I might not be diabetic in the future, which is something that I've always worked towards. It's why I became a biology major in the first place. It's why I'm planning on going to medical school after. So it's really nice to know that there's hope for the future. So I want to thank Dr. Mrincheva for believing in me and helping me through this process. I would like to thank Bridgewater State University for putting on this event to allow me to speak, and I would like to thank you for listening to me speak. Hopefully you learned something new, and I hope you have a wonderful day.